Okay, continuing, just tons of examples of how to simplify radicals. Hopefully you can find stuff in here that's helpful. So I'm going to do the cubed root of 88. Well, let's do prime factorization. Now I know a lot of you are going to want to go with 8 and 11, but don't do that, guys. Always start with the lowest prime number first and then go up from there. It will just make your life simpler. So 2 times 44, 2 times 22, 2 times 11, and I need 3. And see how simple it is? All the numbers are right there together. If you start with 8 and 11, then you're going to have your numbers all over the place, and it's going to be hard to circle your groups. So a 2 goes on the outside, so this is 2 times the cubed root of 11. And remember, guys, be sure to say this correctly. If you are not saying the word times between these, then you're going to end up messing things up, because when we get to later stuff, because you aren't going to know what's going on with this number and the radical. So 2 times the cubed root of 11, just a reminder. Okay, another example. 4th root of 162. Well, I have no idea what the 4th root of 162 is, so I'm going to do prime factorization. That's going to be 81. 2 doesn't go into that, but 3 does. 3 times 9. 3 times 3. Big Boss says there has to be 4 in my group. So a 3 because he's covered up. He's encircled with a blanket or a coat, whatever you want to think, gets to go out of the house in the cold. So cubed root, not cubed root, 3 times the 4th root of 2. And remember, whatever the original index was to begin with, that has to be the same. The answer has to have the same index. If you did this like this, you now have 3 times the square root of 2. You now have an entirely different answer. Okay? Let's do another one. So the cubed root of 500 over the cubed root of 2. Well, I look at this and I think, 2 can go into 500. So let's rewrite this as the cubed root of 500 over 2, all in one. And then we'll do the cubed root. 2 goes in 250 times. Now I just need to find the cubed root of 250. So we'll do prime factorization. 1, 2, 5. 1 plus 2 is 3, and 5 is 8, so 3 doesn't go into 8, so 3 won't go into this either. But 5 does 25 times. 5 times 5. Big Boss says that there needs to be 3 in a group. So I only have 1, 2, but I do have 3 5s. So 5 times the cubed root of 2. Okay? Let's try the next one. So the 4th root of t to the 36. Well, how many 4s are in 36? There are 9, and nothing left over. So I'm done. Easy as that. 3, the cubed root of b to the 19th. So how many 3s are in 19? Well, there are 6, because 6 times 3 is 18, but then there's 1 left over, and he can't come out. So b to the 6th times the cubed root of b is my answer. Let's look at the next one. We got the cubed root of x to the 9th, y to the 16th. So how many 3s in 9? Well, there are 3, and nothing left over. So there isn't going to be any x's underneath the radical. How many 3's in 16? Well, there's 5, but there's 1 left over because 3 times 5 is 15 plus 1 is 16. So my final answer, x to the third, y to the fifth, times the cubed root of y. Let's just keep doing some more. Cubed root of 250w to the fourth, x to the 16th. Remember, guys, I say I work with the number first and then each letter individually. So let's start by figuring out what the cubed root of 250 is, or what the lowest terms of that would be. So that's 125, 5 times 25, 5 times 5. Oh. Okay, so a 5 comes out. I'm going to leave some room in case some other stuff comes out, and a 2 stays in. So you see, now I'm done with the numbers. I don't even have to think about that anymore. Now, how many 3's in 4? Well, there's just 1 and 1 left over. Okay, so the 1 gets to come out and the other one has to stay underneath. 3 plus 1 is 4. How many 3's in 16? There are 5 and 1 left over. So that's my answer. Okay, let's look at another one. The cubed root of h to the 17th over 125 k to the 21st. Well, there's nothing here that I can divide and all that kind of stuff. So, to make this easier for me, I am going to rewrite it as a cubed root in each one, numerator and denominator. So now I'm just going to work with the numerator. So how many 3's in 17? There are 5, remember, times the cubed root, and there are 2 left over. Is this 2, the exponent here, equal to or greater than the 3? Nope. As long as the exponent is less than our index, then we're good. Okay? The cubed root of 125. Well, 3 doesn't go into it, so 5 times 25, 5 times 5. Oh, look, and that's an even root. So, 5. I don't know. Let's see, how many 3's in 21? Oh, that's 7, so that's also even. And there's my final answer. Okay, let's do some more. I have 6.5 minutes left, so let's see how many we can get in. So the cubed root of 28 times the cubed root of 2. So the indexes are both the same. I'm multiplying, so I can multiply these two things. 28 times 2, that's 16/4. So 56. Now I just need to find if I can reduce the cubed root of 56. So 2 goes into that, well, 28 times, just did it, right? 2 and 14, 2 and 7. Big Boss says 3 in a group. So 2 times the cubed root of 7. Remember, the guys who get circled get to come out. The guys who don't get circled have to stay in the house. Let's look at the next one. Cubed root of y squared times the cubed root of y to the 17th. Well, both indexes are the same, so I know I can multiply these. The y's, that base is the same, so I keep the base and add the exponents. Now I just need to reduce this. So how many 3's in 19? Well, there are 6, because 3 times 6 is 18, leaves me with 1 left over. Okay, and I got one more. Yep, one more. The fourth let me write it correctly, the fourth root of 48t to the 11th over 3t to the 6th. Now, here I can do dividing and stuff, so I want to leave all of this underneath the one radical instead of separating it out. Always look and see what works best for you. Sometimes separating it, sometimes leaving it underneath. 48 divided by 3 is 16. My t's are both the same, so I can divide those. I keep the base, subtract the exponents, and remember, wherever the exponent is higher, that's where it's going to be. So in this case, the numerator, I've got nothing left in the denominator. 11 minus 6 is 5. Now I just need to reduce this, so I'm going to use prime factorization all the time. It works so well. Big Boss says 4 in a group. Look, that's an even root. So 2. How many 4s in 5? Well, there's just 1, and there's 1 left over. And that's all of them I have for this section. I hope you find something that helps you.